For our project, our group analyzed a Harbor Freight impact driver. A compact driver such as this is a single-use drill that uses internal contacting components to translate torsional force using a spring downward to make drilling easier. As you can hear in the video, there's a sound of knocking internally. That is the metal driving head contacting a DC motor head that uses this spring to translate the force downward. To better understand this, our group took apart the impact drill and looked at the internal parts so that we could ID sources of air. The first source that was seen was the battery pack. Although detachable, it wobbled quite a bit when attached to the DC motor and could possibly hinder the ability for the drill to contact the electrical component of the battery and limit the drill's ability to have current flowing through it. Therefore, in our supplementary memo, we addressed this issue. Another source of error that we saw was with the impact head component with the DC motor. To expose this, we initially removed 4 screws so that the impact head component could be seen. As you can see here, there's already a great bit of wear and scraping of the impact head, and this could wear down over time. And this contacts a DC motor head that hits these two planes so that the torsional force of the contact translates downward. Here you can see the top head of the driver with its the silver body and 2 extruded heads. To better understand how that component works, we removed the plastic sidings of the drill to get a better look at the internals. Here you can see the internal basic components of the drill. There's a black box that controls current to the DC motor in the silver cylinder that is connected to the gearbox in the clear plastic cylinder, which then connects to the silver extruded body. There are also 2 red switches that were ID'd as possible sources of air. Here you can see us removing the 2 switches that will be talked about further in detail to follow, as well as removing the DC motor and the gearbox with the driver head. When testing the drill, it was noticed that an internal motor switch that made with plastic was hard to switch back and forth so that the drill's speed and forward and reverse could be activated. This was an area that we looked at thoroughly in our memo, as well as the directional switch as areas of possible failure, due to the fact that it was difficult to switch between forward and reverse, especially if the gearbox cannot be set correctly. This could cause damage to the driver. To finish the analysis of the impact driver, the gearbox was removed from the DC motor driver. Here you can see us removing the 3 screws connecting the 2. And first you can see the gearbox covered in lubrication and a metal plate covering 3 gears. You can also see here the drive shaft of the DC motor with 5 teeth that fit perfectly within the circle of the plate to turn the gears, turning the motor head. It was tested at the beginning of the experiment that the speed of the impact driver the max speed was around 2,000 RPM, which is about 1/5 the maximum of a DC motor of this size of around 10,000. Therefore, a gear ratio of 1/5 was hypothesized before the taking apart of the impact driver. This was confirmed whenever we observed this planetary system of gears that followed this ratio. After analyzing this and seeing the torsional component, the drill was put back together as our understanding was now complete of the impact driver.